Greetings, my dear students. A very warm welcome to this new platform, which is also new for me. So I was browsing through this website, and with the help of my senior, I came to know about this website and got a run through of all the features of this website and found it to be very informative and a very good tool to reach out to you as an extra resource that you can use at your home also. So there would be certain topics that I may not touch, like when we are rushing through to finish our portions, we're preparing for our checkpoint exams. Some important yet small topics may be left out when we do our lessons. So I felt that this platform would be a great source of information and a resource which you can use even at your home. So once I send you this link, you can refer to it anytime. So the topic that I'm going to take today, it's a very short topic but yet important. It has its own importance in nature. And the topic, as you can see on the screen, is isotopes. So you must have come across the word a number of times when you were doing your reading in chemistry, when we were learning about the structure of an atom, or when we were doing the electronic configuration of atoms, and when we were just going through the periodic table. So this topic, what basically I'm going to touch upon is your just a minute. I am not able to. Yeah. So the objectives that I'm going to touch upon is we're going to define an isotope. What is it about, and what is importance, and understand the atomic structure of isotopes. So before we touch on this topic, we take the term isotope, I just want to give you a quick run through of what we have learned so far on the fundamental structure of an atom, because that is what leads to this topic. So the fundamental structure of an atom, as you can see over here, this is the structure of an atom that you can see, and the shells, and the one that is here in the center is your nucleus. Okay, so what are the basic structure? What do they contain? So the structure of an atom, you can see here there are three fundamental parts of an atom. We have already learned it, but just a brush through so that it will be easier for you to understand what are isotopes. So there are three fundamental parts of an atom. There are protons, electrons, and neutrons. So here you can see this is the nucleus, as it says, which contains your protons and neutrons. And these are the electron shells where your electrons are orbiting. Now, the protons and the neutrons, as well as electrons, they are found, the protons and the neutrons, they are located in the nucleus, and your electrons are located outside of the nucleus. Now, these protons, electrons, and neutrons, these are the subatomic particles which have certain charges. As you can see here, the electron, they have negative charge. The proton, they have positive charge. And neutrons, they are neutral and they have no charge or almost negligible. They are not considered. So the relative mass also you can see over here. The electrons don't have a mass. I mean, they are almost negligible, like 0.000 in negative. So it is considered as 0. Proton have 1 unit and neutron also has 1 unit of relative mass. So moving ahead, you can see here, now before this I just show you, this is your periodic table wherein your elements are placed, and you can see there are a lot of numbers you can see over here. So as each element proceeds from the left to the right, you can see the number over here on the top. If you can see my cursor moving, there is 3, 4, 5, 6 and so on. These are the proton number of your element, and that actually determines the position of the element in the periodic table. So the number of protons in each element is the identity of that element, which doesn't change, which gives that identity in the periodic table. Now as you can see over here, how is it represented? So this is the element symbol that you can see over here, and you can see here the mass number and the atomic number. Now atomic number, we have already learnt about it. The atomic number is your number of protons that you see. So your atomic number is same as the proton number. For example, if it's sodium, the atomic number would be 11 and the mass number would be 23. You can see over here the atomic number here given is 11 and the atomic mass is 22.9, which is rounded to 23. So that's how it is represented. So basically, so we have also learned what is the mass number. How do we get this mass number? Now this mass number is the nucleon number. Alright, the other name for mass number is the nucleon number, which we get from the nucleus. That is the sum of your protons and your neutrons. So the addition of your protons and neutrons will give your mass number. And your atomic number, as I told you, is your proton number. So that's how you get your values for the element. So what this is the basic information that I wanted to give you, which you've already learnt. So moving ahead, what are isotopes? To make now this word often is quite confusing when we use in chemistry. We always think about how these exist in nature, or as you saw in the periodic table, these are naturally occurring elements in nature, and how the isotopes would be generated. Okay, so what basically isotopes are? Now let me give you some examples which will make it more easier for you. Look at this picture. Now these are identical twins. Alright. Now it's quite difficult to say or to differentiate these twins unless they are very closely observed or examined. For example, if they're if they are weighed separately, maybe one twin will be heavier than the other, and so on. So that's how we are able to differentiate them. But basically, they both are the same. All right. Let me give you another simple example, and that is on say a vehicle. Okay. For example, you can take Toyota Land Cruiser. Okay. You have different versions of Toyota Land Cruiser. So initially there was J30, Land Cruiser J30. Then they came up Land Cruiser J50. Then came up Land Cruiser J200, which is also going on right now. Then you have Land Cruiser Prado. So they all are different versions of the same vehicle or same brand, that is Land Cruiser. So in chemistry, when we talk about elements, there are different versions of the same element. All the elements in the periodic table have different versions of them, which are present in different amounts in nature. So apart from the naturally occurring elements, there are some isotopes or different versions of the same element, but basically they are same. So isotopes, as you can see over here, they are atoms with the same number of protons. That is, the basic thing doesn't change. The proton number doesn't change, but there is a difference in the number of neutrons. Okay, so atoms of the same element or same atomic number, but with different mass number. There's an example given over here of the atomic number of chlorine, which you can see over here, chlorine 35 and chlorine 37. Now, the naturally occurring is chlorine 35 with the atomic number 17, but you can see an isotope over here where the proton number still remains the same, or the atomic number remains the same in both, but a different version or an isotope which has the atomic mass of, the mass number of 37, because there is a difference in the number of neutrons. So that's what I meant to say is in chemistry there are different versions of the same element. As you can see over here in the example, chlorine has an isotope. Same way, we have other examples where I've just taken out some examples for you. Isotope of hydrogen, where you can see there are 3 different isotopes for hydrogen, and hydrogen being the simplest element, you can very well see how the number of neutrons is taken. Okay, as I told you, to calculate the number of neutrons, you need to minus the atomic mass from the atomic number. So, for example, the number of neutrons is 1. So, you minus it with the atomic number 1, which comes to 0. And number of neutrons, which comes to in deuterium, which is another isotope, and tritium, which is a third isotope, which has 2 neutrons. So in this way, you can see that the number of protons or the atomic number of hydrogen doesn't change. But the neutrons, you can see there is a number, the change in the number or the mass. So likewise, the mass of that element also increases. So basically, hydrogen will be acting in the same way as it is naturally as it is, but the mass of the other isotopes will be different from the naturally occurring one. Same way over here also, you can see the isotope of carbon. You can see here the different isotopes of carbon also. For better understanding of this topic, I have a QR code for you, which is a video link. Please please scan this and watch this video for better understanding. If you have any queries with this, please get back to me, and while I come to class, you can watch this video and come back to me with your queries. So thank you so much. I have a worksheet also which I'll be giving you tomorrow. So happy learning. God bless you.